Good morning, all. This is R. Naveen, lecturer in physics, Government Polytechnic Forum, Warangal. In today's class, I am going to explain about kinetic energy and potential energies. Okay. So first of all, kinetic energy. So, what is kinetic energy? Energy is of many forms, is in many forms. In all those forms, in our daily life, we come across many types. Those are light energy, kinetic energy, heat energy, sound energy, electrical energy, chemical energy, all those things. Okay. In these things, what is the kinetic energy? In our daily life, we see many things which are in motion, which are moving. That means which has some velocities. When we try to stop a moving object, we have to do some work. To stop the moving object, we have to do some work against that moving object or against the direction of the motion. Then only it can be stopped. That means the moving object possesses some energy. Okay. So that type of energy, which is possessed by a moving object, is called kinetic energy. The kinetic energy of a body is due to its motion. That means we can define the kinetic energy can be defined as the energy possessed by an object due to its motion is called as kinetic energy. Okay. So if a body possesses velocity, then only it possesses kinetic energy. If the velocity of the body is high, then the kinetic energy of the body is also high. If the velocity is low, then the kinetic energy of that body is also low. Right? That means kinetic energy is directly proportional to velocity. Exactly, kinetic energy is directly proportional to square of the velocity. Okay. The kinetic energy not only depends upon velocity of the object, but it also depends upon mass of the body also. If the mass of the object is high, then kinetic energy is also high, and if the mass of the object is low, then the kinetic energy is also low. So by this, what we can say, the kinetic energy of the body directly proportional to the mass. Okay. So let us see some examples for kinetic energy. So all the bodies which are in motion possess kinetic energy. Due to their velocity or due to their motion, they gain some energy. That energy is called kinetic energy. For example, energy possessed by a moving car. A car which is at rest do not possess kinetic energy. It cannot do any work. But while it is in motion, due to its velocity, due to its motion, it possesses some energy, kinetic energy. While it is in motion, if an object is hit by the car, then that object will be displaced for some distance. That means the car does some work on the object by using its energy. That energy is kinetic energy. And another example is energy of a bullet fired from a gun. When a bullet is in the pistol or bullet gun, it has no energy, but after firing, the bullet gains velocity and moves fastly with a greater velocity. In that time, the bullet has some kinetic energy. And some more examples are flowing water, energy possessed by a running man, etc. These are some examples for kinetic energy. Okay, and next let us derive an expression for the kinetic energy. We know that kinetic energy depends upon mass, and the exact relation is kinetic energy is directly proportional to the mass, and it also depends upon square of the velocity, directly proportional to square of the velocity. But till now we did not derive any expression for the kinetic energy. In this session, let us derive that expression for the kinetic energy of a body moving with a velocity v. Okay, so look at the picture. So let us consider an object of mass m which is at rest on smooth horizontal plane. So let us consider an object which is at rest and the mass of the object is m on a smooth horizontal plane. Which is at rest means initial velocity is 0, it is not in motion initially. After that, let a force F is applied on the object in any arbitrary direction. A force F is applied on the body. Then what happens? The force tries to move the object in the direction of force. Okay, right? So gradually, due to the applied force, the body gains velocity, and when a net force acts on a body, that body possesses some acceleration also. What is acceleration? Rate of change in velocity. That means for every second the velocity changes. If the force is in the direction of motion, the acceleration increases. The acceleration is positive, that means velocity increases. If the force is in opposite direction to the motion, then the acceleration is negative. In that case, the velocity of the object decreases. Here, the body is initially at rest. It has no motion. It is not in motion. When we applied some force, this force tries to move the body in the direction of force only. Then the body slowly moves in the direction of force. Hence, the force and the motion of the body is in same direction. Then the acceleration of the body due to the applied force is positive. Okay, due to the positive acceleration, the velocity of the object increases gradually. So after moving some distance, after having some displacement s, let the velocity of the body is v. Let the velocity of the body is v. Okay, so let us find the kinetic energy of the body after it gains the velocity v. When the velocity of the body is v, let us find the equation, or let us find the kinetic energy of the body. Okay, so the energy gained by the body is due to the work done by the applied force. We know that work is converted into energy and energy is converted into work, vice versa. When we do some work on an object, that work is stored as energy in that object, or when we utilize our energy gets converted into work. So the amount of work done is equal to amount of energy utilized, or the amount of work done is equal to the amount of energy gained. If we do some work on an object, the energy of the object increased in the same extent as work. Okay, so in this case, the kinetic energy is due to the kinetic energy gained by the body is because of the work done on the body. Who did work here? The applied force F does some work on the body. This work is converted into energy, and this energy is stored in the moving object as kinetic energy. So the kinetic energy of the body is equal to work done on the body. So if we want to find the kinetic energy of the body, then we have to find the work done on the body, because both are equal. So if we find work done, then it is equal to kinetic energy. So first of all, let us find the work done on the body. Right? So what is the work done? The work done on the body is, any body is, force, applied force into the displacement of the body. W is equal to Fs. Yes or no? Okay. But we know, according to Newton's second law of motion, F is equal to ma. So W is can be written as ma into displacement s. Right? So now what is the a? We know m is the mass of the object, a is acceleration of the acceleration possessed by the object, s is the displacement of the object. So let us find what is this. Let us find the displacement of the object s. Okay, then we will find the substitute that s value in this equation number 1. Okay, so before for displacement, let us observe the value data. The initial velocity of the object is 0, the final velocity of the object is v, acceleration is a, displacement is s. So from these 4 parameters we have a relation, that is equations of kinematics. We have an equation v square minus u square equal to 2as. Yes, by substituting or by rearranging, s is equal to v square minus u square by 2a. This is the displacement gained by the object. But by Newton's second law of motion, F is equal to ma. Okay, from equation 1 and 2 we have, what is equation 1? W is equal to Fs. What is F? ma. Ma into what is s? V square minus u square by 2a. So in this case, a and a gets cancelled, and the initial velocity is equal to 0. After substituting, we remain with W is equal to mv square by 2. That means the work done on the body is half into m into v square, where m is the mass of the object, v square is the velocity of the object. Okay, but what we know, the work done on the body is equal to the kinetic energy gained by the body, the kinetic energy possessed by the body. So therefore the kinetic energy of the body is equal to half mv square. Understand? Right. So let us solve some problems on the equation related to equation of kinetic energy. Okay, the first problem is example 1. A car is traveling at a velocity of 10 meters per second and it has a mass of 250 kg. Compute its kinetic energy. Find its kinetic energy. So simply the given data is, velocity of the car is 10 meters per second and the mass is 250 kg. But what is the equation for kinetic energy? Half mv square. Simply substitute those values. Kinetic energy is equal to half into m, that is 250, into v square, that is 10 square. So that gives 12,500 kg meter square per second square. So actually the units for kinetic energy, SI units for kinetic energy are joule, and the CGS units are eggs. Okay, so and 1 joule is equal to 10 power 7 eggs. These conversions are very useful in solving some problems. 1 joule equal to 10 power 7 egg, and the dimension formula is ml square t power minus 2. So please remember these things. Okay, so the answer for this problem is 12,500 kg meter square per second square. So that is kg meter square per second square is called joule, nothing but joule. So 12,500 joule or 12.5 kilojoule. So let us solve another problem. A man is transporting a trolley. A man is transporting a trolley of mass 6 kg and having kinetic energy of 40 joule. Compute its velocity. Compute its velocity with which he is running. With which it is running. So a man is transporting a trolley of mass 6 kg and having kinetic energy of 40. So find the velocity. That's it. Okay. So given mass is 6 kg, kinetic energy is 40 joules. So from the equation, the kinetic energy of equation of is equal to mv square equal to ke. So we have to rewrite its equation for the velocity. So of ke is equal to half mv square. From that we can write v is equal to 2 ke, 2 into kinetic energy by m is equal to v square. So square root applies. After applying square root on both sides, v is equal to square root of 2 ke by m. In this, after substituting the given data, velocity v is equal to square root of 2 into k is 60 40s. K is 40 joules by 6. K is 40 and mass is 6. Forty joules only. Okay, right. So that is 3.65 meters per second. The velocity of the man or the velocity of the trolley is 3.65 meters per second. So this is about kinetic energy. Right. Next, let us discuss about another form of energy, that is potential energy. Okay. So the kinetic energy is due to the motion of the body, but the potential energy is different. Potential energy is due to the position. The energy is possessed by a body due to its position. Position means it is at higher level or lower level with respect to a reference level. Suppose let us consider a reference level, that is surface of the earth. If an object is on the surface of the earth, the potential energy of that body is considered to be 0. If we change the position of the object with respect to surface of the earth, that means if we increase the height, if we lift that body up to some height, then its position is changed. So due to that height, that position, it gains some energy. That energy is called potential energy. If the height from the surface of the earth is more, then the potential energy of that body is also high. Okay, and in another example, let us see another example. Let us consider a spring. You know the spring. Okay, at its mean position, the energy of the spring is potential energy of the spring is 0. How can we say? That spring cannot do any work at that position. If we stretch that spring for some distance, after some elongation, the spring gains some energy. In this case, the state of the spring is changed. Due to change in its state, because of its state, the spring gains some energy. How can we say? After stretching the spring, let us attach an object to that spring and left, and if we leave the spring freely, the spring tries to move the object, and it moves, it displaces the object. So the object attached to the spring is displaced. That means the spring does some work on the object. Okay, when the spring is at mean position, the spring do not displace that body, cannot, not do not and cannot displace the body, because it has no potential energy at that position. After changing its position, that means if we compress the spring or if we stretch the spring, then the spring is able to displace the body. That means the spring gains some energy because of its state. If the stretching is more, the work done by the spring on the displacement of the object is more. That means the energy gained by the spring is more. If the stretching is less, then the energy gained by the spring is also less. So this energy gained by the spring due to its state is called potential energy. So for potential energy, I have given two examples. In first example, an object is lifted for some height from the surface of the earth. In that case, due to its change in position, the body gains some energy, potential energy. That type of potential energy is called gravitational potential energy. First one is gravitational potential energy. It is due to the gravitational force acting on the body. When a body is lifted for some height by us, we have to do work. We have to apply the force on the body against the gravitational force. That means we do some work on the body against the gravitational force to lift the object. So this work done against the gravitational force is stored in the object as potential energy. So this is the work done against the gravitational force. That's why this potential energy is called gravitational potential energy. In second type, we, in stretching or in compressing the spring, after compressing or after stretching, we can feel that some forces are developed inside the spring. Those forces are called elastic forces. If we stretch the spring, that means we are applying the force to stretch the spring. We feel that from inside the spring, some force is pulling our hand in opposite direction to the stretching. Those forces are elastic forces developed in the string. So in stretching or compressing the spring, we are doing work against the elastic forces. So this work done against elastic forces is stored as potential energy in the spring. Okay, so this work done against elastic forces is called elastic potential energy. So there are two types of potential energies, gravitational and elastic potential energy. So let us explain gravitational potential energy now. So what is gravitational potential energy? The energy possessed by a body at a height from the surface of the earth. When a body possesses gravitational potential energy, when it is at a height from the surface of the earth. So due to that position, due to that height, it gains some energy. That energy is called gravitational potential energy. Okay. Let us derive an expression for the gravitational potential energy. Okay, So let us consider an object of mass m. Initially it is on the surface of the earth. Now after applying some force against the gravitational force, let the body is lifted through a height h. Okay, that means the position of the body with respect to reference level, that means with respect to surface of the earth, is changed. Height is increased. Height from the surface is increased. So in this process, in raising the height, in lifting the object through a height h, we have to do some work against the gravitational force. Okay, so this work done against the gravitational force is converted into potential energy of the object, right? Now we have to find the expression for gravitational potential energy. But we know the gravitational potential energy stored in the object is equal to the work done on the object against the gravitational force, or negative of the work done by the gravitational force is equal to work done against the gravitational force. Understood? Is this clear? The work done on the object against gravitational force is equal to the work done, negative of the work done by the gravitational force. Is it clear or not? The work is not done by gravitational force. Work is done by us only. But the work done by us is equal to the negative of work done by the gravitational force. Yes or no? So negative of gravitational work done by the what is negative of work done by gravitational force? Actually work done is equal to F into S, force into displacement. Okay, here let us find the work done by the gravitational force. What is work done by the gravitational force? Force into displacement. We know gravitational force is equal to mg. Mg gives the gravitational force. And what is the displacement of the body? H. So displacement is h, gravitational force is mg, but both are in opposite direction. Therefore displacement is considered as minus h, or force is considered as minus mg. Both are equal. So the work done by the gravitational force is mg into minus h, that is equal to minus mgh. Okay, so this is the work done by the gravitational force. But the work done on the object against gravitational force is equal to negative of the work done by the gravitational force, that is minus of minus mgh. So therefore work done on the object against the gravitational force is mgh. So this work done against the gravitational force stored as gravitational potential energy of the body. Understood? So the gravitational potential energy is equal to mgh. Okay, so what did I just explain? Potential energy. What is potential energy? Energy possessed by an object due to its position or state is called potential energy. Okay, if the potential energy is due to its position, then that type of potential energy is gravitational potential energy, and the example for that is any object which is at a height from the surface of the earth. Okay, flying birds, airplanes, helicopters, a stone which is thrown upward, all these things possess gravitational potential energy. When they reach the surface of the earth, then their potential energy becomes zero. And the second type is elastic potential energy. Example, I have already discussed that the stretched spring, when a spring is stretched, it possesses some potential energy due to elastic forces developed in that object spring, or when it is compressed also it possesses elastic potential energy, and a stretched rubber band possesses potential energy due to elastic forces. And when a balloon which have air inside the balloon, when it is compressed, we can feel that some force is pushing our hands outside. So it is also, when an air balloon is compressed, then it gains potential energy. These are examples for potential energies, and this is gravitational expression for the gravitational potential energy, that is mgh. In this, m is mass of the object, g is the acceleration due to gravity, and h is the height from the reference level. So in this case, the reference level on the earth's surface, the reference level will be taken as surface of the earth. Okay, mgh. And now let us solve one example for the gravitational potential energy. Okay, right. A box has a mass of 5.8 kg. The box is lifted from the garage floor and placed on a shelf. In the box, if the box gains 145 joule of potential energy, how high is the level? So in the problem, the given data is there is a box of mass 5.8 kg, m is given, and the box is lifted from the floor. That means it is lifted from the surface of the earth and placed on a shelf. There is a shelf at a height, some height. The box is placed on that shelf, right? In that process, the box gains 145 joules of potential energy. Gravitational potential energy gained by the box is 145 joules. Now find the how high the shelf is. How high is the shelf? Okay, we have to find the h. So all of us know the gravitational potential energy is mgh. Here we know the value of m, and the value of g is 9.8 actually, or in some problems it is taken as 10 meters per second square g, and we know the potential energy also. Now we have to find h. So from PE, potential energy is equal to mgh, we get h is equal to potential energy by mg. Okay, so now after substituting those data, given data, P is equal to 145 by m is 5.8 into g is 10. So we get the height is 2.5 meter. 2.5 meter. So what can we say? The shelf is 2.5 meter. The shelf is 2.5 meter high. Okay, so this is about potential energy. Two types of, and in this class we have discussed two types of energies. They are kinetic and potential energies. So what is the kinetic energy? The energy possessed by a body due to its motion is called kinetic energy. Examples, any example we can give. Any body which is in motion possesses kinetic energy, right? So the expression for the kinetic energy is half mv square, where m is the mass of the object and v is the velocity of the object. And from one more relation is also there between momentum of the object and kinetic energy of the object. We know the momentum. The product of mass and velocity gives the momentum. P equal to mv. There is an important relation between kinetic energy and the momentum. So So how can we derive it? How can we get it? P equal to mv, Ke equal to half mv square. Okay, so imagine or remember that equation, K equal to half mv square. If we multiply this equation, multiply and divide half mv square with m, what can we get? Half into m square v square by m. Okay, K is equal to half into m square v square by m. Yes, but what is m square v square? P square, because P is equal to mv, hence m square v square is equal to p square. Therefore kinetic energy is equal to half into p square by m, or p square by 2m. So this is the important relation between kinetic energy and the momentum. K is equal to p square by m, or from this equation we get P equal to square root of 2m into kinetic energy, 2m into K. This is C. So these two relations are very important in solving problems. Relation between kinetic energy and momentum. Kinetic energy is equal to p square by 2m. And next, potential energy. There are two types of potential energy. One is due to the position of the object, and one is due to the state of the object. Okay, both are called potential energies only. So the energy possessed by an object due to its position or state is called potential energy. If the potential energy is gained due to the potential position of the object, then that energy is called gravitational potential energy. That is due to the position from the surface of the earth. If the potential energy is due to the elastic properties, or the potential energy is due to the state of the object, or it is bent, or it is stretched or compressed, or like this, then that type of energy is called elastic potential energy, because this potential energy is due to the work done against elastic force developed in the stretched or compressed object. Okay, and the expression for the potential energy, gravitational potential energy, is equal to mgh, where m is the mass of the object, m is mass of the object, f is force, g is acceleration due to gravity, and h is height through which the object is lifted from the surface of the earth. And the units for the potential energy, SI units of potential energy are also joule, and CGS unit is erg. What is the relation between joule and erg? 1 joule is equal to 10 power 7 erg. So same as kinetic energy and same as energy, and the same is for work also. The joule is the SI unit of work, energy, kinetic energy, and any type of energy. Work and energy possess same units, because work is converted into energy and energy is converted into work, vice versa. Okay, so therefore dimensional formula is ml square t power minus 2. So this is about potential energy, gravitational and elastic potential energies. Okay, thank you.